Thank you very much, and thank you, Jason, for the introduction, but also thank you, Datadog, for giving me the opportunity to speak. And actually, it's closing out. I think it's been a very enjoyable conference. How about a hand for Datadog and everyone there? So I've been introduced. And why am I up here? Because I consider myself an ops professional, and I've been in the industry for 20 some odd years. Started way back doing value-added reselling, installing WebSense across South Carolina. Spent some time at the state of South Carolina as a backup and recovery administrator, Unix administration. That was probably the low point of my career because as part of the state of South Carolina, we had disaster recovery testing. How many have enjoyed the thrills of disaster recovery testing? Exactly. So 1,100 LTO4 tapes boxed up in a van, driven to Philadelphia. Does not make for a good weekend. But since then, spent some time at Oak Ridge National Lab, spent some time in the Bay Area working and consulting in a number of great companies, Airbnb, Pinterest. But these days, I've landed at Starbucks. I've been there for about a year and a half, really enjoying the experience. And the common theme across most of these roles is I'm jumping into environments and getting started with environments that I've not seen before. I mean, everyone experiences that. We're ops professionals. We're expected to just make it work. And what are we making work? We don't know. We haven't seen it before. And even now, in my position at Starbucks, it's kind of an internal consulting position because I'm helping out individual teams with their ops challenges. I don't necessarily know their infrastructure. If I'm lucky, I'm given a diagram. More often than not, I'm sitting with that team for a week or two to figure out what's going on, what really matters, and what's important. And so often, the experience is this. It's jumping out of a perfectly good airplane to go fight fires and to put things out and hopefully bring some sanity and rein, some coordination and control to whatever that burning landscape looks like. I think we've all been here. I think the rest of the industry actually calls this imposter syndrome. But you operate in the environment, you learn it, you survive, you endure, and as time goes on, things get better. So this is a lot of our ops experience. Should it be our ops experience? So from that 10,000-foot view, this is how I answer the question of what should I be doing as ops? What does it take to do this, though, is a very large question because, again, every experience that I've jumped into, every company that I've jumped to has a completely different array of instrumentation, different systems they've got, different applications they're running. And so the mix of skills that it takes to bring all this together quickly balloons and becomes some Cartesian product, figuring out, okay, what am I doing here? What am I doing now? How am I applying all these ops skills to make this thing better, to make this thing work? The one thing that really isn't captured is the fun part of our jobs, that is pop-up quizzes. And so at 3 a.m., we get some alert saying the site is down and we're debugging across that environment, trying to figure out, well, what's working, what's not working, how do I check this? I thought this was working yesterday. Was there a change that maybe upgraded the load balancers? Was there a change of the application version? I don't know. Let's run some curls across the environment. Let's run some other commands just to figure out what's going on. Knowing the environment is absolutely critical. So here's a survey for you. How many of you, seasoned professionals that you are, can draw your infrastructure stack from the top of your head if I were to pull up a whiteboard right now? Draw your stack. Ooh, so some people are already struggling with this. I experience it every day, no worries. But separately, of those people who had your hands raised, how many of you could take me back to your documentation wiki and point at a diagram that actually reflects that infrastructure? Yes, gold star right here. But for the rest of us, this is a large capacity room and the documentation isn't there. The overall sitemap isn't there. The orientation, the landscape of what we're doing, we're having to wing it. We're having to figure out as it goes along. And we don't just need this at 3 a.m. We need this every day, day in, day out, as we're making control changes in our environment. And making control changes, knowing the current state, making sure that it's doing, that everything's A-okay as we're working on this, because the worst thing we can do as professionals is to make a change and not know how it was impacted. So we test our current state. We ask ourselves what that change is going to do to our environment. We actually go ahead and make the change, and then we start to validate. Is that change actually working how I want it to? And then, boom, we only close it out once we actually know. And so all the skills distills down what I experience as an operations professional on a daily basis. I started with the analogy of smoke jumping and 10,000-foot view jumping out of an airplane. I like starting off with that big picture approach because you see the landscape of what's happening. You're jumping into the area, you start working on it, and having that 10,000-foot view gives me a good perspective on what systematically has to be done in this environment. And so I want to take an aside just briefly and call out this good work. This is from Chick-fil-A's tech blog. Caleb Hurd and Laura Jausch, if I'm getting her name right. Caleb, sharp engineer, is actually a manager for Chick-fil-A SRE and created this distillation. And what I like about it is it tries to answer that same question of, as ops, as SRE, what am I trying to do? Let's break it down on some goals, and let's break it down on some tactics of, here's day-to-day operational stuff we can be working on and improving to make our infrastructure and environment better. And I really like this structure because it does that, but it also gives us a chance to step back, reflect, and ask those bigger questions. And what excited me about first encountering this diagram was because I immediately started asking the question of, what business measurements, what business metrics are we capturing to reflect that our goals are actually being achieved? So I sent off a note to Caleb, and then we'll see if version 2 comes out. So we've taken a good look at ops, and the buzzword du jour is DevOps. And devs are those wonderful engineers that create all the features that our sites do use to attract customers, which is a good thing, because if you relied on me for those features, you'd be getting 1995 HTML page with burning flame across the bottom. I don't do dev. But we've brought together, we have DevOps, and all is right with the world. Obviously, because we're at a conference talking about this stuff. No, my common experience is this, which is an improvement from last week, because last week it was 47. So things get better day by day. But we have this conversation, dev, ops, back and forth, sharing knowledge, tactics, concerns, and having this, again, fruitful conversation around what can we do better, what can we make different. And so to take a moment and reflect, we now practice on the ops side software development lifecycle as far as our infrastructure. We use Jenkins to make sure that every time we've got our Terraform or what have we, every time we go to make a deploy, it's done in a consistent and repeatable manner. We know exactly where that's happening from. Terraform is tracking that state file for us, keeps it in a good place, takes care of that, and pushes it out. But it's a life cycle, so we've got these controlled changes we're making through time. We also have invented this idea called immutable infrastructure. Let's containerize our applications as much as possible. We started with Packer and AMIs, and so our blue-green deployment said, well, spin up a new batch of AMIs in AWS, switch the load balancer, move on. And because we now have contained units of what our application server is doing, we can reason about it. We can know that, well, version old of the container and version new of the container, this is the only difference, because we've got those version numbers, we know what that should be, we can inspect that, and we can track it and move forward. Separately, version control is my favorite. It's a time machine. Not only do I see what changed through time, if I need to go back to that previous version, it's right there. It's waiting for me. And one of these days, I will be so good as to be able to git bisect my infrastructure as code, but I'm not quite gotten that far yet. But infrastructure as code kind of compiles all this stuff together. Let's go ahead and make sure we have a declarative configuration so that our tool takes our intent and goes out and applies the thing. Or separately, if we're using Ansible to deploy our infrastructure, we declare our imperative steps of do this, do that, and we've got repeatable, organized, understandable, readable deployments that we know what's involved. We don't have junk sitting under somebody's desk. And so it's been a very fruitful conversation, but our developer brethren have tons of great ideas, and I don't think we've exhausted the entire conversation. I think there's more to learn. And one idea that I think is ripe for plucking is test-driven development. How many are familiar with test-driven development? A good amount. For those who may not be as familiar, the mantra is red, green, refactor. Write a failing test, stand that up, watch it go red, it's not gonna pass, we haven't written our code yet, we're good. But because we have a test, now when we write that first code, we run it, the test now passes, it's green, and we build ourselves a little bit of safety net, a little bit of infrastructure, so that when we go back and refactor that change, we can watch the performance. We know we've not regressed, we know we've not lost any functionality because that test is still passing. And in practice, with Python, we write a unit test, it's gonna fail the first time we run it. Secondly, maybe we write a stub function to build things out, that's still going to fail. But moving on, we write our first version of the function, hello world, great, it returns hello world. We've done the bare minimum necessary to make sure that our code is doing what it should be doing. Success, let's go have a beer. But sometimes you need to do a little bit more before you call it the end of the day. So you think, well, what am I gonna be doing in the future? What am I gonna care about? Let's go ahead and build in a little bit more. So here I'm extended the function to just be a little bit language aware. So when I come back the next day, boom, write my second test, test it in English, it just happens to be the default language because I'm a default English speaker. But then also add some capability for Spanish. Again, it's still failing because we haven't actually written the code yet. Write some code to get it out there. Okay, great. Now it's green, and the test is working the whole time, making sure that as we're making changes. So with this idea, adding this infrastructure, it's an investment. We have to take extra time to write the code, to set it up, to make sure everything's working. It's a pain in the butt. I just need the things to work because there's beers going on and I want to get out to the party. What are we buying with all that investment? Sanity, speed. Without tests, you've got people going crossways across traffic, you've got people mixed in with the vehicles, you've got different rates of speed, you don't have control. In a tested environment, you've got guardrails, you've got appropriate lanes for traffic to go in, it's much easier to organize, and traffic as a whole moves much smoother. It's a good idea for devs. Is it a good idea for infrastructure? Well, implicitly, I'm going to say yes. I'm the speaker, I'm up here, that's what I chose to talk about, but how do we make this happen? Well, our framework is still the same. Write our test, write just enough infrastructure to make it pass, and then we have the freedom to refactor as necessary. But what tests? How would we even begin to generate tests? What kind of tests are we looking for? What kind of code do we have to write? We already know what kind of tests because we're operating these kind of tests on a regular basis. As we're making our control changes, we're already doing this somewhat. We don't have the infrastructure in place, we don't have the testing framework in place, but if we're making discipline changes, we know what the infrastructure is, we measure that infrastructure before we make our change, and then at the end of it, we test to see that the change is doing exactly what we need it to do. So here, we've got curl statements peppered throughout it. Let's apply that to our infrastructure. So before we even write up our first Terraform deployment for our infrastructure, great. Let's see if we even get a result. I make a curl call, it's gonna return 404. It does it very fast. That's kinda nice. I've got speeding on infrastructure, but it's ultimately failing because it's not there. But set up an Nginx server, maybe do a deployment behind that, and then immediately I can see, hey, look, it's now operating 30 milliseconds. Maybe that's fast, maybe that's not, but more importantly, 200. Our infrastructure is doing exactly what it needs to do. I don't have to worry about it as an ops person. The developers are now free to go off and create their own test environments to see it working for themselves. There's bliss and sanity in the world. But when they need to come back and refactor that and say, well, users are never going to put up with 30 milliseconds, great. They have the freedom to refactor. They can improve that scenario. They can improve that situation. And in the simulated example, they drop the response time to 12 milliseconds, so progress. I would like to think I'm the first person that says test-driven development's a good idea. Obviously, I'm not. We have this in the configuration management world. Puppet has RSpec, does its thing. It's nice here in this example. We're testing, is Nginx out there? Is it available? Is it doing what it needs to do? And it works. It's nice. Chef does the same thing. Excuse me. Chef does the same thing. It uses a language called inspec, previously used server spec, whatever. We have evolved. Inspec, again, in this example, we're doing much the same thing, but it's happening at a very low level. We're checking the package. We're checking the port. Well, not really. We're just checking that it's up and it's running. We're actually not testing the content that's happening at all. But I give the Chef example because, again, I do feel this progress. I particularly appreciate in the Chef environment that Test Kitchen integrates everything very nicely and gives a more cohesive experience in building. Separately, moving on, a tool you may not have heard of that I'll draw your attention to is GOS. It's a small daemon. It's written in Go. It has a couple features that I find particularly convenient. In a base mode, it does GOS validate, takes its configuration file and does a one-time check of, is this infrastructure operating appropriately? Yes, it is. No, it's not. So one-time check. Separately, you can use the GOS daemon in a serve mode, and then it stands up its own HTTP endpoint, constantly runs that validation check, and so you can point your monitors at it and get a long-term idea of what's happening and how that's working. Separately, a convenience that I'll notice here, GOS also has the feature of you can point at an existing process and it captures the parameters of that process, such as port numbers, PIDs, process names, system D statements, so whether or not it's enabled and true. So it can actually auto-configure itself when you point it at it. So getting started with GOS is very easy to do. So we have tools to unit test configuration management. And so this is good stuff. Our systems are provisioned more accurately. I've got a framework so that when I go to refactor this stuff, I haven't regressed. I know I've still got the same functionality that I want. But let's try this litmus test. If I've got broken infrastructure, if I've got broken infrastructure at 3 a.m., can I run this tool to help me identify what's broken and what I need to fix? Sadly, no. These tools are great, they're awesome, but again, they're happening at the configuration management layer. If I'm doing any sort of image building, then that's probably happening even before my image gets baked and goes into infrastructure, or excuse me, goes into production. So it's a one-off kind of feel. Separately, let's look at another area. Kubernetes. How many people operate Kubernetes? Decent sized. How many people actually have Kubernetes in production? Wait a minute. There are more hands for Kubernetes in production than for Kubernetes. Maybe I woke somebody up with the question, so thank you. But if you're using Kubernetes, hopefully you're familiar with liveness probes. Okay. Do you have them implemented? Okay, small number. Readiness probes as well? Okay. So for the rest of the room, the idea is simple. Because Kubernetes is a container orchestration environment, our containers are bundled up in pods. As Kubernetes is putting those pods into production, a liveness check is a constant check that Kubernetes can make to say, hey, this thing is functioning as it should be. Because of that, if it's not functioning as it should be, the orchestration system says, well, I'm getting a review, you're broken, and it will go ahead and spin up a replacement, which is nice. A readiness probe is a very similar idea. It's written very much the same way. But the mechanism is a little bit different. Rather than killing it after it's live, it has a delay. The readiness probe is the delay before it actually starts directing live traffic to it. So we've got a good deal of control around what's healthy and what's getting good traffic. In this particular example, we're using the health C endpoint. We're using just an HTTP check. You can use command lines. And so just wrapping this up for an earlier tool, you can go ahead and wrap it up with GOS and then get a more full-featured check around, is that application behaving as I want it to? And I'm calling this out specifically because if you're migrating old applications that existed as standalone in your infrastructure, you can capture that with GOS because of its auto-discovery, containerize everything, and then run your GOS check, and you can still have a like for like, hey, it was working before, my tests were passing, now that I moved over here, my tests are still passing, I'm good. So I like that safety net. So we also have tools for functional testing, and I'll go back to the litmus test I used before. If I've got broken infrastructure, can I use this to help identify what the problem is? And now answering this question is a little bit tricky, because to a limited degree, yes. it's fixing errors before I even know I have them. If I've got a failed pod, it's replacing them, but not in all cases. Well, it's fixing them in all cases. I'll still have whole classes of errors that aren't going to be addressed by this approach at all. Pod restarts, if I've got a crash loop, it's going to keep on crashing, it's going to get the count. I'm not putting bad pods into production, but depending on what's happening, I can still resource starve myself or just lose my total pods. And so as an approach, we're maturing, but I think there's still more mileage. So stepping up, smoke tests, right? As part of our Jenkins deployment, relying on some of that continuous development that we've got going on, let's write, as part of our Jenkins file, a validation test. And in this particular example, I'm using the inspect pod to check at deployment time, is the application, now that it's deployed, running as it should be running? And here, using the HTTP resource, going ahead and fetching that main page as it should be, capturing that down. I've passed it some host parameters just to get a feel for if I'm trying to understand, is this overall application in a healthy state on deployment time? I've got to check for that. Now, the approach is going to be a little bit error prone. Here especially, when I've written the test and inspect, for convenience, if I ever need this instruction during a troubleshooting scenario, I'm probably not going to run inspect because I was running in a pod, setting up the environment, may or may not be convenient. A little bit more portable is curl, but now all of a sudden, as far as maintaining the stuff, I've got to make sure my curl matches my inspect in all cases. So maybe I should have just written the thing in curl to begin with, but I don't know. It's a good approach, but just because of tooling, it just doesn't seem to come together quite how I want it to. So again, the question is, can I use this kind of test to troubleshoot it, to troubleshoot an application if it's broken? And yes, because I have the test encapsulated, I know what I'm trying to check for, I've documented what the application or how the application should be checked, but it's still not complete because inherently this check is only running at deployment time, and hopefully, or more likely, my bug hasn't happened at deployment time. If it has, then I've managed it, I've backed it out. But at 3 a.m., hopefully nobody's doing a deployment, unless you have colleagues like some of mine. But it's not happening at 3 a.m., and so this test hasn't run, and it's not returning useful information back to you. If you know it's there, you can go grab it, run the test manually, but then you're still testing one component of your entire application stack. And so you've missed all that other stuff going on. And you want these tests to run continually. You want them running so that errors are caught and that information is returning to you as quickly as possible. So we have some tests. We know what they don't look like. So let's forget not everything I've said. Let's forget about the past 5 minutes of review material and imagine, okay, we want this test-driven development thing. We want this red-green refactor. We know we've got some workable tests. How do we make it happen? So maybe in an ideal environment, what I'm doing is defining 200 counts, response count. Just basic, is my site returning mostly healthy responses? That's what I want it to look like. Let's write a failing, it's a test. It's going to fail the first time. How do I write just enough infrastructure code to make it pass? And here's where Datadog comes in and helps me out quite a bit. If you use the Datadog Python package, it's got a component dog shell. And I find this quite convenient. It gives me a command line access to most of my Datadog components. So again, I had a 200 error count, or excuse me, 200 results count monitor that I'd already created. Here, dog shell will actually allow me to dump that. Why is that useful? Well, if I've dumped it, I can stash it in a file. In a file, I can put it in my version control repo. I know how that's changing over time. I know how that's improving over time. More importantly, though, what I really want to do is put that automated check right alongside my microservice code. And then every time I check in that repo, every time I make updates, let's automatically deploy that check and make sure it's consistent. And so conveniently, there's now a feature in Dog Shell to go ahead and update that from a recorded JSON snippet. And so how would that work? Well, let's go ahead and take that JSON, dump it out, put it in a monitor file at the root of our repo. This is a just hopefully getting started repo. The developer said, I need a new microservice. And I said, yes, yes you do. Go out and write it. And so the first thing he's going to do, or she's going to do, is write her Docker file. She's going to stub out her Jenkins file. And then I step in and say, hey, what do you need this microservice to do? And then we sit down, we write a monitor file to say, oh, okay, well, let's make a check. And let's look over the last 5 minutes, response volumes, and we want them to be over 95%. Maybe that's a good number. Maybe that's a bad number. I just wrote a test. I don't really care at this point. I can come back, I can revisit it later, but I've got a definition of some amount of health for that microservice. And deploying that in my Jenkins file was also relatively straightforward. I can go ahead and add a stanza to my Jenkins file that just says, hey, go ahead and run that dog shell command and get it there. So here, I focused on the test being, maybe it's accurate, maybe it's not. What are good tests? Again, I started with the observation that jumping out of an airplane, I've got a nice 10,000-foot view. I was said that as an ops guy, I want to make sure the user's happy. So for me, when I start asking questions around what tests should we be writing, I come back to, what do users notice? And there's some very great material in the Site Reliability Workbook and the Site Reliability Engineering Guide from Google that starts talking about this, and they distill it down into SLIs and SLOs. And an SLI, if you're not familiar, is just a metric or a monitor that represents the entire service well, and SLO is the distillation of that into a policy. It's the goal we want for that individual SLI. And in my example, if I step back a couple slides, you'll see that I was just checking response rate. But best practices, latency, saturation rate, traffic rate, and error rate are all good things to check. And so I've distilled these down into a file. I've put it with my microservice. It's getting deployed alongside. And a next feature that Datadog comes in with is they've just released SLO Monitoring with Datadog. So now, because I already know and I've identified from the start of the application code what's important about that, I wrap that up with a conversation with the business around, what do you care about? How much investment do you really need for this microservice? Is it user-facing? Are they going to notice when it goes down? Are we justified in spending $10,000 an hour to keep it up? And they'll say, haha, no. That's why you're using open source. They'll come back and they'll say, oh no, it's probably appropriate at this level. It's a healthy conversation, it's a good level, it's a good conversation, and we just codify what that appropriate level of investment is. So from that, we create very nice dashboards that let us know if we're inside that error budget or if we're outside that error budget. And that error budget is a very nice concept that takes that packaging of SLOs and then says, hey, if you're operating in advance of where you think you should be, run wild, have fun with it. You've got some time to burn. Or alternatively, if you've had a lot of crashes over the past couple of weeks, then maybe you're trending under your error budget. It reminds everyone that, hey, we're burning through this stuff too fast, or we've gone a little bit too faster than we want to be. Everyone needs to shift down, be more focused around stability and features, and just be more mindful of how we're proceeding in our development and what features we're choosing to deploy and how we're choosing to deploy them. So I've got a good deal of control, or I've got more control around the pace of development and the pace of deployment. So in this monitor file approach, I've got those checks that I care about alongside the application code, the microservices that I care about. And deploying in a consistent manner, I've now shifted left on all that discussion around what do we need to monitor, why do we need to monitor it. It's happening from the start of the microservice creation. And I don't have to care as much about following this stuff all the way through. I'm not building out the telemetry for the production system after it's in production. It can follow me through staging, through QA, and then into production. And then at the start of go live, I've got pretty decent control around how that's operating and what I'm seeing with that. And so should it go down, whereas in this case, I've got an error drop, which is kind of a bad thing, but I've got an error drop on the on the application servers right here, which a quick glance between the different graphs say, haha, well, yeah, I've got airdrops right here in the application stack because on AWS and in the database, it returns relatively strongly. After this minor glitch, let's go and check out the applications first. So why should you care? If you're not an ops person in this room, I totally get you, but I will advocate that this kind of approach is good for devs, it's good for ops, it's good for interns, it's good for managers, because in seeing that infrastructure, by making sure that we get that infrastructure built in from the start, a sense of scale, a sense of performance, a sense of application architecture is all cohesively built in. And then as we move forward, the whole team understands it better. So I'd encourage you, as an ops, advocate that operability should be a design consideration. Build it in from the start.